Okay, whoops, optical marker. Okay, it is day 263 off the grid, and it's a big day for the 24 volt system, the main 24 volt system in the main power room, and that's what we're looking at right now. The heart of the system, of course, is the stacker charge controller, and that's going to stay, but what's going to totally change is this arrangement here, which is, what would you call it, a booster, a power multiplier, a slave. It's basically, at the moment, this is the MOSFET here, which is actually controlling the power from the solar panels. And I'm going to be swapping this out for a new board that does exactly the same thing, except that it switches on the positive rail instead of on the negative. In other words, it's high side switching, because this one actually switches low. So these are the negative returns to a couple of the solar panels. These are some of the other negative returns. So from the negative of the battery post here, it goes back through the diode and the MOSFET, and it switched on the low side. Well, I don't want that. I want it switched on the high side, so my new board is going to switch on the high side. And it's also got a diversion function, which will allow excess power to be diverted to another set of batteries or another load, whatever I want. So it's going to be a major improvement, because as you can see, this is already reaching regulation mode. In fact, when it does this red flash, that red flash actually means it's shut down entirely because of over voltage. So it's barely midday, and it's not even that sunny today. It's kind of a bit, it's not that bad, but you know, there's a bit of cloud. It's not really overcast as such, but there's a bit of cloud, and it's already constantly regulating. Needle's just down, stuck over there. This reads up to 20 amps, this meter, and it's only doing about 2.5 because it's PWMing away. Now all that extra current that those panels could be potentially making could be diverted somewhere else. So that's what the new circuit's going to do. So I thought I'd just film this kind of for the last time before I take it apart. I've already filmed it before, as I've made slight improvements previously, but this next improvement's going to be the biggest and pretty much the final. Well, apart from improving that improvement, but you know, it's pretty much going to be the way I want to run this part of the system permanently. But of course, this stuff here will be retasked to be something else, no doubt, so it's not going to be wasted. Nothing ever is, so I might as well stop filming, maybe take a couple of photos, and then get on with it. So probably the next time I start the camera, you will see the new board in here installed. Okay, it's day 263 off the grid. Well, technically it's day 264, but I ran out of time yesterday to do this, so I thought I'd just show you the circuit installed. Here's the Realtime PWM diversion circuit. I haven't got any diversion on here at the moment, but it's working as a standard charge controller, but a positive earth system, common, I mean not positive earth, common negative, so positive's actually switched, which is what we wanted, because most of these cheap controllers, of course, switch the negative and have positive as the earth essentially, but we want negative as the earth so that we can connect other things up, like to this diversion output. As you can see, the LED's flashing away, PWMing, the needle's flickering around as you'd expect. The only thing I had to do to get this to behave itself a bit better was to install this 2.2k stopper resistor, which I actually had in the previous version of this, but I had this connected up just before without this resistor, and it was sort of making the charge controller go into spasms a little bit more often than it should. I mean, sometimes the voltage gets a bit high on the battery because of the powerful solar panels connected, and this will go into over voltage mode and just cut the output, which is fine because then it'll divert the power. But I thought it should have been spending more of its time in PWM mode rather than on-off mode, so I've added that resistor, and that seems to settle it down. I mean, I may even experiment with the values because I've got a lot of gain available with these transistors. I could possibly increase that to, I don't know how much. Obviously, I don't know how much. It must, as well as be, I call it a stopper resistor, because it's the kind of thing you used to put on, you know, small resistors on the grids of valves and stuff to stop issues, parasitic oscillations and whatnot. Well, I call it a stopper resistor because it stops certain issues I was having, but maybe it's actually what it's doing is it's lowering the pulses, and so it's essentially shortening the pulses, which maybe is better. I don't know. I'll have to experiment with that. But I arranged it this way with a clip lead so I could test that, because I knew I might have to, and I've also got a spare terminal here on this connector so that I can put a resistor in series with the input rather than just have it connected directly. So yeah, so it's working pretty well. I'm pretty happy with it, eh? I had some issues yesterday when I installed it. I ended up blowing up a transistor, punch through voltage, because well, here's the replacement there. I put a BC109 in there just because I felt like it, just because I wanted to put a metal can one for a change. I would normally save them for audio. But what the problem was is there's a little diode there which protects the base of that transistor, because that transistor's base gets pulled well negative of its emitter when the power is turned off. But the diode I had in there inadvertently, it was a surplus diode that I pulled out of a board, and it tested fine on the meter, but what I hadn't considered was maybe it could be a Zener diode, and guess what, it was a Zener diode. So that was a bit of an issue. When I was testing it on the 12 volts it was fine, because the Zenering probably kept the base of the transistor high enough to protect it, but as soon as I put it on 24 volts it had the ability to pull that base down a lot lower. So yeah, it was a problem. Just using this as my boost battery at the moment. I will organise some more permanent boost battery setup, but I'm not sure what yet. But that's what I'm using for now, and it'll do the job, and it will last for ages. This circuit only pulls about 1.6 milliamps. The LED is powered from the batteries that it's charging, so it doesn't come out of this battery. It's a little bit higher than my original circuit, because the original circuit used sort of resistances in the order of 120, 150k, whereas this one I've used more like 33k and 56k, just because I wanted a bit more current to hit the MOSFETs, which I think has been worthwhile because they are very, very cool. In fact, I think this is overkill. I think that's overkill. This heatsink here is nice. This is only lukewarm, and it was only just warm earlier when it was charging at full current, so that's good. And I'm about to run out of memory on my phone, so I better turn this off now. But anyway, you've seen it working, so it's working and it's cool, and this is something I've wanted to do for a long time, so I'm very happy that it's done. So see you later.